Hi everyone. Today we are diving into the concept of cross validation, a super handy technique in machine learning. So let's make it fun and easy to understand. So imagine we have this cool data set with information about how well people sleep, how much water they drink, and their daily junk food habits. This data set helps us predict whether someone will end up with health conditions or not. Now, we have just 20 rows in this dataset for simplicity. To find the best model among k nearest neighbors, decision trees, and logistic regression, we will use cross validation. So, what exactly is this cross validation? It is like a reality check for our models. It helps us figure out how well our model will perform on new, unseen data. The idea is to split the dataset into several parts, train the model on some parts, and test it on the remaining parts. It basically answers the question which model is best for my dataset. So let's break it down and first see k-fold cross validation. So picture this. We split our dataset into k equally sized parts. Suppose k is 4 here. So we divide the data into 4 folds. Each fold has 5 rows. Then we train and test the model in such a way that each time we use one fold for testing and other folds for training. That means here, first the first 3 folds of dataset are used to train the KNN model, and last set is used for testing. We store the performance of each iteration. We repeat this until each part has had its turn as the testing set. Then we calculate the overall performance. This process is repeated for all the machine learning models we want to check. This gives us a solid performance evaluation for all models we want to compare. We check which model performs best on unseen data and use it further. Now, let's see stratified k-fold cross validation. It is similar to k-fold, but it's a bit smarter. It ensures each fold has a proportional representation of each class. So, if our dataset has this split where 40% are positive and 60% negative cases, then in case of k-fold, some sets would have all negative cases and some would have all positive, which would hamper the working. So, here's how training and testing data would look like for k is equals to 4 in stratified k-fold cross validation, where same ratio of positive and negative is maintained in both training and testing data. It's like making sure each team in a game has a fair mix of players. Now, let's see leave one out cross validation. Here, each data point gets a moment to shine as the testing set, while the rest train the model. It is perfect for tiny data sets, but watch out. It can be quite a task since it involves many repetitions. For our 20-row dataset, we train 20 times, each time with 19 rows for training and 1 row for testing. Repeated k-fold cross validation. This one is all about consistency. We repeat the k-fold process multiple times with different random splits. For example, if k is 4 and we want to repeat this 5 times, then we end up 20 training and testing iterations. It's like checking your work multiple times to ensure robustness. So there you have it. Cross validation is essential for evaluating and selecting models in machine learning. By applying it to our dataset, we can confidently choose the best model among KNN, decision trees, logistic regression, and other models. This ensures our chosen model will perform well on new, unseen data, giving us reliable and robust predictions. That's it for this video, and I'll see you in the next one.